Oumuamua, an enigmatic interstellar object, puzzled astronomers when it was first detected. However, NASA's James Webb Space Telescope, the JWST, has managed to unravel the mystery by capturing the first real image of this strange cosmic traveler. Could this object have an extraterrestrial origin, as some experts suggest? Join us as we explore the secrets hidden in Oumuamua and reveal the surprising truth. What implications could this revelation have for our understanding of the universe? On October 19, 2017, an unusual object called Oumuamua was detected speedlining through our solar system. The celestial body had traveled for more than a century before being identified. It reached a significant cosmic milestone in 1837, but astronomers failed to see it then. Oumuamua crossed our solar system for decades, and despite its steady speed, neither astronomers nor telescopes were able to detect it. Robert Warwick, a scientist at the University of Hawaii, observed a faint, elongated spot in the sky captured by the Pan-STARRS 1 telescope, which revealed a fast-moving object unlike anything seen before. Initially, scientists thought Oumuamua might be a comet because of its strange behavior, even though it was located in the asteroid belt between Mars and Jupiter. However, later observations showed that Oumuamua was moving away from the Sun at an unusual speed. The absence of visible outgassing on Oumuamua confused scientists, as its acceleration defied predictions, leading to reconsiderations of its classification as an asteroid or comet. One of the most striking aspects of Oumuamua was its steady brightness that dimmed every 7.3 hours, suggesting that the object was rotating, probably on its shortest axis. The speed implied that Oumuamua was a solid object, with a stronger and more durable composition than most comets, which are usually fragile. Its red dark color, similar to moons in the outer solar system, indicates that it's been exposed to cosmic radiation for millions of years, which has altered the composition of its surface. As experts examined the data, questions arose about the true nature of Oumuamua. Some proposed the idea that it could be an advanced extraterrestrial probe or a decommissioned alien spacecraft. Other more conservative theories suggested that it could be an unknown comet or asteroid, or even a relic of an exoplanet ejected during a catastrophic event in another star system. However, there is still no consensus of what exactly Oumuamua is. Determining its future trajectory has been complicated, as it is moving away from the Sun and exiting our solar system at a steep angle. Current estimates indicate that Oumuamua will return to interstellar space, where it will continue its slowly journey across the universe. The discovery of Oumuamua in October 2017 has generated intense debate and interest among astronomers, scientists, and the general public. This unusual cosmic object, the first of its kind to be detected, has given rise to a number of theories seeking to explain its origin and nature. Is it just a normal cosmic object, or could it be an alien probe sent to investigate our solar system? Let's delve into the theories and evidence that have emerged to unravel the mystery of Oumuamua. Initially, astronomers classified it as a rocky object, possibly an asteroid. However, its extreme elongated shape, approximately 800 meters long and 8 meters wide, does not resemble any known asteroid or comet in our solar system. As more data became available, it was hypothesized that Oumuamua might be filled with gas, which would explain its unexpected acceleration away from the Sun. Then came the surprising suggestion that it might not be a natural object, but an alien spacecraft. The unusual properties of Oumuamua, especially its non-gravitational acceleration, reinforce this theory. Comets usually release gas and dust as they approach the Sun, causing them to accelerate, but in the case of Oumuamua, no such outgassing was observed. This led some researchers to explore less conventional ideas, such as the possibility that it is a probe sent by an extraterrestrial civilization to observe Earth, although although to many this sounds more like science fiction than plausible reality. One of the most intriguing concepts was proposed by renowned theoretical physicist Dr. Michio Kaku, who suggested that Oumuamua could have been ejected from a distant star during a supernova explosion. On the other hand, billionaire Elon Musk raised the possibility that the object originated from the collision and merger of two celestial bodies, giving rise to a unique hybrid form. Initially, astronomers were pleased to rediscover that Oumuamua trajectory appeared to point towards Vega, the brightest star in the constellation Lyra, known for its debris disk. Estimates indicated that Oumuamua could have taken about 600,000 years to reach its current position from Vega. However, this theory was soon discarded when it was found the object's path has changed during its journey. Astronomers concluded that if it had probably passed close to another star system before entering our solar system, since its velocity was similar to that of nearby stars, suggesting that Oumuamua could have been traveling through the Milky Way for billions of years before reaching our system. Another fascinating theory suggests that Oumuamua is a fragment of nitrogen ice. Researchers Alan Jackson and Stephen Dash of Arizona State University proposed that it could be a piece of Pluto-like objects broken off by a massive impact. For this theory to be valid, Oumuamua would have to be much smaller than originally believed. However, the nitrogen ice hypothesis has gained popularity as it may explain both the composition of the object and its unusual acceleration. One of the most significant discoveries was that Oumuamua was traveling in a hyperbolic orbit, a boomerang-shaped trajectory, clearly indicating that it did not originate in our solar system, but it was passing through and would never return. This revelation sparked speculation about its future visibility, with many believing that Oumuamua would disappear into space never to be seen again. However, the object's behavior defied expectations. Although the gravitational forces of large celestial bodies such as planets and stars can accelerate smaller objects such as comets and asteroids, these cannot fully explain Oumuamua's acceleration. Its velocity reached 54 miles per second, about 3 times the average velocity of comets in our own solar system. This anomaly led experts to reconsider its final classification as an asteroid, and many began to speculate that it might be something else entirely. In most comets, acceleration is due to outgassing, but in the case of Oumuamua, no such process was observed. The presence of detectable outgassing in Oumuamua added to the mystery surrounding this interstellar object. Typically, comets exhibit acceleration as they approach the Sun due to the sublimation of volatile materials such as water ice, which creates jets of gas that propel the comet forward. These jets are usually visible as a comet's characteristic tail, but Oumuamua did not display any visible tail or coma, did not exhibit any signs of gas or dust that could explain its acceleration. This lack of outgassing led scientists to reconsider alternative explanations for its unusual behavior. One hypothesis proposed that Oumuamua could be a fragment of a larger body, possibly torn apart by tidal forces during a close encounter with a star. This scenario could account for its elongated-like cigar shape, which is unlike anything previously observed in our solar system. However, this still did not fully explain the acceleration without outgassing. Another intriguing possibility suggested by some researchers was that Oumuamua might be an artificial object, perhaps a piece of an alien technology, or a probe sent by an extraterrestrial civilization. This idea was fueled by the object's peculiar shape, which some argued could be consistent with a light sail, a thin, flat object propelled by radiation pressure from the Sun. A light sail could theoretically achieve acceleration without the need for the outgassing process, as the pressure from the sunlight could push it along its trajectory. While this theory captured the public's imagination, it remains highly speculative and lacks direct evidence. If you liked the video, remember to like and subscribe.